So here we go. So we're going to learn how to write exponential functions based on what information that you're given. So the first one we're going to do is if they tell you like where does it start and then how fast does it grow or how fast does it shrink. And we're going to write the equation. Now just to review, your growth equation is y equals a times 1 plus r to the power of t. And your decay equation is y equals a times 1 minus r to the power of t. And for a growth equation, of course, it increases as time passes. And in a decay equation, it decreases as time passes. For both growth and decay, the a value is your initial amount. And by initial, we mean that when time t equals 0. How much did you start with? In both equations, the lowercase r is the rate, and the rate is in its decimal form. So it's a percentage rate of growth or a percentage rate of decay. All right, we're going to do an example. This says you deposit $8,343 into an account that pays 7.3 annual interest every year. How much money will you have in 5 years? Write an equation that could be used to solve this problem. So let's say that you have a goal. I had a goal of I started a mutual fund, which does not make that much. But I started it to pay for dental costs because as you get older, you need more dental work and it's in the thousands. So for like my retainers to get my teeth straightened was about $6,000. So I needed to know how much do I have to put into the account and then how long do I have to wait until I have enough money to pay for them. So can someone tell me, is this growth or is this decay? It's growth, yeah, because you're getting 7.3 interest, which means your money is going up. So that means that the equation that we're going to use is the growth equation. So then you want to identify what numbers you've been given. So in this equation, your A value is $8,343. That's how much you started with. Your percentage rate R is 7.3%, but we don't put the percent into the equation, we do its decimal form. So to get its decimal form, you divide by 100%. And the percents cancel, and it ends up being 0.073 is your rate. So once you have the rate in decimal form and the initial amount, put them into the growth equation. So here we go. Y equals $8,343 times 1 plus 0.073 to the power of t. And you always add the 1 and the percentage rate together to get your final form. So in parentheses, it's going to be 1.073 to the power of t. And that is your equation. So the question is, how much money are you going to have in 5 years if you keep doing this? So t equals 5 years. So to figure that out, you're going to substitute a 5 for the t. So y equals 8,343 times 1.073 to the power of 5. And then this is definitely a calculator question. So using your exponent properties, you always do the power before you multiply because exponents come first. So I'm going to do 1.073 to the power of 5, enter, and now I'm going to multiply times 8,343, and at the end of 5 years, I'm going to have $11,866.45. Like I said, that's an extremely high interest rate on an account. Usually if you get 3 or 5%, you're having a good year. But I think it took me 10 years. And I didn't start with 8,000. I just started putting money in each month. So, and then at the end of 10 years, you have roughly $15,000 to pay for dental stuff. Highly recommend that you do that. Okay, so that's our first example. So now example 2. Example 2 says you deposit $255 into an account that's frozen due to a lawsuit, but still it charges you 3% each month in fees. This actually happens. How you can't take money out. You have to just leave it there and they can charge you all the fees and you can't actually pull the money out and use it. Yeah, nice. So it still charges you 3% each month in fees. How much money will you have in 18 months? Let's say the lawsuit's going to be over in 18 months. How much are you going to have left? Write an equation that can be used to solve this problem. So tell me, is this growth or is it decay? It's decay, yeah, because you're losing money with those fees and you can't put anything in. Okay, so this is decay. Okay, so our initial value was $255, so that's our A. And then the rate is, it's 3% in fees. So to calculate the rate, we take 3% divided by 100%. The percents cancel out, and I have 3 divided by 100, which is 0.03. All right, now we're going to put this into the decay equation. So y equals A, which is 255 times, and I'm going to go ahead and add the 1. It's 1 plus 0.03, so 1.03. I'm sorry, you have to subtract. Excuse me. I added, this is decay, so you have to go 1 minus 0.03 to the t. This is decay, not growth. So that would be 0.97 to the power of t. Remember that growth, the growth rate should be over a 1 when you add it. And in decay, it should be less than 1. So that's how come I immediately knew this was wrong. Because I'm like, wait a second, this is decay. It can't be 1.03. It can't be over 100%. It has to be something else. Okay, so then the question is, how much are we going to have in 18 months? So if t equals 18 months, we're going to calculate that. Y equals 255 times 0.97 to the power of 18. So again, you always do the exponent first. So 0.97 to the power of 18, enter. And then we multiply times 255. And we get $147.38. So there'll be a little bit left, but not a whole lot. Okay, so that's how you write an equation given the initial value and the growth or the decay rate. Okay, Roman numeral 2. Now we're going to find growth or decay from 2 points. And for these questions, you're going to be using not the population equations, which are the ones that we were just using, but you're going to use the simplified one, which is y equals a times b to the power of x. And in these equations, your a is still your initial value, but it's always positive. That's something you want to remember. B is the base, which is also always positive. If you end up with a negative number in either one of those circumstances, then your answer is extraneous and there is no solution. They must be positive. Okay, and then just a reminder, let's say that you get b to the negative 1 equals 5. Remember that anything to a negative exponent, it's 1 over b equals 5 over 1, because it's Once you flip it, the 1 becomes positive. It's b to the positive 1. And then as far as solving, if you just have two fractions and you want that b up top, you just flip. You do flippy step. You flip both sides, and that gives you b equals 1/5. So that's a solving move that you're going to be using with a great deal of frequency in these new problems. Yeah?
What is it called when you have two negatives?
What is there what?
When your A and B are negatives, what is it called?
Extraneous. Yep. All right, so let's do an example. All right, they've given you 2 points, 1, 3, and 2, 36. And they've told you it's growth, which means it's going to be y equals a times b to the x. And because it's growth, b should end up greater than 1. All right, so we are going to use substitution method. So what you're going to do is substitute these two values into your growth equation. So I'm going to use this one for x and y. And then on a different equation, 2 and 36 will be a different x and y. So for the first one, when I fill in the x and the y, I get 3 equals a times b to the 1. On the second one, I get 36 equals a times b to the 2. So you replace the x and the y and make two different equations. Now we're going to solve this using substitution method. We want to substitute one into the other. Of those two, which one looks like the simpler equation? First one. Yeah, there's no power of 2. So you want to pick the easy one and solve for that one first. So I'm going to solve for a, which means I'm going to multiply both sides by 1 over b. So I get 3 over b equals a, or a equals 3 over b. So I solve for a, and then I substitute it into the second equation. So that gives me 36 equals 3 over b times b squared, which would be 3b squared over b. Now here's where your exponent property comes in. To divide exponents, you do top minus bottom power. So the 3 doesn't move, but it's b to the 2 minus 1, which is 1. There's your exponent properties in use, and I'll put that out here. B to the 2 minus 1 equals b to the 1 over 1. That's what we just did. Okay, so now that we have a single b, multiply both sides by 1/3 to get the b alone. This is regular solving. So b equals 36 divided by 3, which is 12. Once you have your b value, you go back and you substitute it into the first equation. So a equals 3 over 12, which reduces to 1/4. So now that you have a and you have b, we're going to put the equation together. So the x and the y go back in, and we get y equals a, which is 1/4, times b, which is 12, to the power of x. So you just fill your a and your b back into the growth formula. Basic substitution. Solve one equation for one variable, substitute it into the other one, solve it for your first answer, take your answer, go back to the first equation and get your second answer. All right, we're going to do one more of these. Okay, in this one, your points are 2, 2, and 4, 18. This is going to be growth. So y equals a times b to the x, and b is greater than 1 because it's growth. You can actually get the equation without knowing if it's growth or decay, but sometimes it helps you check your work. Okay, so we're going to substitute 2 and 2 in for x and y. So 2 equals a times b to the 2. And then the second equation, we're going to substitute in for x and y. We get 18 equals a times b to the 4th. Okay, so here's where this is a little different than how we did substitution. Little bit, not big difference, is sometimes you can't get a simple equation. So just pick the lonely only and solve for that one first. So I'm going to get rid of the b squared. So I'm going to multiply by 1 over b squared. That gives me 2 over b squared equals a. So a equals 2 over b squared. All right, now I'm going to substitute that into my second equation. So 18 equals 2 over b squared times b to the 4th. Again, we're going to do our exponent property. B to the 4th over b squared is b to the 4 minus 2, which is b squared. So 18 equals 2b squared. Get the 2 off the b squared, so multiply both sides by a half. 18 divided by 2 is 9. 9 equals b squared. Can someone tell me what my next step is in solving? How do I get the b squared down to a b? Yeah, cool. So it's called taking square roots. Yep. So we're going to square root the left, square root the right. 2 b's, 1 comes out. 9 is 3 times 3. So 2 3's, 1 comes out, and we get b equals 3. Now, you go, but Miss Wright, you told us it was plus and minus. Yes, it is. It is plus and minus, but in a growth or a decay formula, A and B are always positive. So we keep the positive one and we disregard the negative one. That one would be extraneous. So yes, B is plus and minus because we took it out of a square root, but because of the formula, we only keep the positive one. All right, substitute back into the first equation. A equals 2 over 3 squared. 3 squared is 9. I get 2/9 for my A. So let's write our equation. Y equals 2/9 for A times 3 for the B to the power of X. And that is your equation. Any questions?